going to start the course nanotechnology in chemical engineering. So, today we will discuss some special nanomaterials, that is fullerene. So, that we will discuss. So, the content is carbon nanomaterials and fullerene. So, carbon nanomaterials we can say fullerenes, carbon nanotubes and other type of materials is available, but today only we will discuss the fullerenes and its synthesis, mechanism of synthesis, its applications, different derivatives. These are the things we will discuss. Okay. So, carbon nanomaterials, so already I have said that carbon it can be forms in various dimension and various way it can be arranged, and it can forms various type of nanomaterials, that may be 0 dimensional, 1 dimensional, 2 dimensional or 3 dimensional materials. So, a particular type of dimensional category. So, we can say that 0 dimensional carbon nanomaterials, that is fullerene. So, that is one of the examples. So, its dimension is all 3 dimensions x, y, z all are in nanometers range. So, therefore, it is called 0 dimensional material. So, other than carbons, quantum dots, nano diamonds, onions like of carbons, that also forms. So, that may be 0 dimensional materials. So, basically these fullerenes materials we will discuss. So, apart from that there are some one dimensional materials also, carbon nanomaterials, that is carbon nanotubes. The carbon nanotubes may be single wall or maybe multiple walls, double walls nanotubes. So, carbons nanofibers also, that is come in one dimensional categories, and the carbon nanofibers also, that we will discuss in another day. So, also 2D type of carbon nanomaterials, that may be graphene type of sheets. So, 2 dimensionals, that is both the dimensions are in nano range. So, that can be forms, or graphene oxides, graphene. So, these are the 2 dimensionals carbon nanomaterials, and 3 dimensionals. So, carbon nanomaterials here diamonds, amorphous carbons, glassy carbons, these are the 3D category of carbons nanomaterials. So, here these are the materials sets, various properties are also present, means only these diamonds that having bonding type of carbon carbon bond type, that is sp3 types. Apart from that graphite, graphenes, that is 2D category, nanotubes, carbon nanotube, that is sp2 category, and fullerenes, that is also sp2 carbon carbon bond type is sp2 types. So, and bond length is very small, 1.54 angstroms, and bond length for graphite graphene is very small, that is also 1.4 angstroms, and band gap in case of diamonds is very high. Apart from that other is band gap is very low. So, even depending upon their bond types or bond structure. So, they are insulators, this diamonds is insulators, and graphite or graphenes, that are metals or semi metallic property they are present. Even nanotubes also semiconductor to metallic type of property, you can say that having, and in case of the fluorines, that having semiconductor type of property. So, various type of materials we have discussed, that can be formed by using various methods, that already have discussed. So, here the graphene or graphene oxides, that is 2 dimensional materials. So, it is this type of graphenes carbon seed hexagonal type of arrangements of carbon atoms, that form a single layer of graphitic crystals. So, that we can say as a graphene. So, when it is oxidized by using any chemicals or substrate, so it can be converted into oxide, graphene oxides, and against that also can be reduced, converted into reduced graphene oxides. So, that way it can be formed. So, it is, I said, hexagonal type of carbon arrangements is there, and single layers is present. So, then it is called graphenes. Otherwise, if it is multiple layers, then that we can say graphites. And when this graphenes is rolled over, so it forms graphenes roll into tubular form. So, then we can say it is carbon nanotubes. Okay. And so, this carbon nanotubes, so when it is forms in the nano form, so it can be, means these graphenes or graphene sheets, that can be separated out by using a scotch tape. So, it is possible when it is a multiples or layers or sheets are available. So, then using the scotch tape it can be separated out a single carbon sheet. So, that was actually superior, this property of this graphenes, it is much more stronger, or mechanical property much more stronger than steel. So, it is 200 times stronger. So, as compared to the steel. So, it has been means discovered or received JM and Novoselov, they have received Nobel Prize by separating these single layers carbon sheets on the year 2010, and that was the breakthrough for the separations of graphenes. So, I said that graphene, that actually hexagonal structures and sp2 hybridizations, it has so many properties, means advantage means lightweight, high tensile strength and excellent conductive, means thermal conductivity, electrical conductivity, that having this type of properties presents, even high surface area, high mechanical optical properties is present in this type of graphenes or graphene oxide, that materials, carbons, allotropes, that is, and it can be means graphenes nano plate type of, or graphene oxide, graphene quantum dot, or graphenes nano ribbons type of different forms we can get that graphene. So, graphenes once it is forms we can convert from graphene to graphene oxide, graphenes, other graphene quantum dots, graphene nano ribbons, that we can forms. Okay. So, it has numerous applications. Also these are the biomedical applications or electronic storage or energy storage device, flexible electronics. So, there it can be applied. So, apart from that, so there is graphene quantum dots. So, that is materials having sizes very small 2 to 50 nanometer, within that range. So, it can be colloidal semiconductors, nanocrystals, that can be forms, or its features is means fluorescence type of emissions, means visible as IR range, that can be, or tunable spectra, photo bleachings, resistance. These are the features this particular graphene quantum dots having or possessing. So, it can be applied many drug delivery, bioimaging, biosensing or cancer therapy, many applications are there. So, then carbon nano dots, that is also new type of nanocarbons, that materials, it is easier to synthesis than carbon nanotubes, and it can be prepared by hydrothermal treatment. So, and also by exfoliations of multiple wall carbon nanotubes. So, from there also by oxidations or exfoliations methods, that way you can separate out, or chemical exfoliations from the graphites, we can prepare these carbons nanodots. So, then carbons nanohorns, that is also another type of carbons nanomaterial. So, here similar like it is single wall carbon nanotubes. So, here it is cone like structure formations is there, means the tubes like single wall nanotubes, both the edge, the dimensions is almost similar, but in case of this means carbons nanohorns. So, this type of cone like shape formations is there, that is why it is called nanohorns. So, it can size 80 to 100 nanometers, within that range the dimensions of that nanohorns or nano carbon nanohorns forms. So, it having size within that range, it has no metal catalyst records when it is formed. So, mostly it is prepared laser ablation methods or reduced cytotoxicity and high internal storage, that features is present with this particular type of materials. And next is carbons nano walls, that is also graphene sheets like materials, when it is stacked vertically on any substrates, then it is formed carbons nano walls. So, it is one kind of graphene sheets when it is vertically stacked or on a surface. So, we can say that it is carbon nano walls type of material. So, it is usually synthesized, I said, when graphene oxides, it is reduced graphene oxide formation is there in presence of titanium catalyst. So, it can be forms these particulars carbons nano walls. So, next is carbons nano diamonds. So, that is also size is very small, 4 to 10 nanometers, within that range. So, it is also combinations of sp2, sp3 carbons hybridizations is present in this particular allotropes. So, it is possessing high surface area, and then it we can synthesize CVD methods or detonations methods at high temperature and pressures, that we have to use to synthesis this type of nano diamonds type of materials. Extremely high temperature and pressures is required. Therefore, the method is very cost effective. So, next is the carbons nano onions. So, that is also means carbons allotropes another. So, it is spherical nested fullerenes like carbon cell formations is there. So, its size is very small, so less than 100 nanometers, and it can be synthesized by various methods, CVD method, graphite electrodes in waters that can be used, or annealing nano dots in inert gas. So, that can be used to synthesize these materials. It can be used for various applications, that is catalysis or any other energy storage applications, lubrications or imaging purpose it can be applied. So, next the properties of the carbon based nanomaterials, already few properties we have discussed. So, These are the materials usually having high specific surface area, thermal conductivity, electrical conductivity and thermal tensile strength, so that is exceptionally from other materials. So, here surface area, these are the nanomaterials having surface area, extremely large surface area, and mechanical properties, exceptional mechanical properties present, and electrical conductivity also. This type of materials having excellent electrical conductors, they are good conductors. Even thermal conductivity also, these types of materials having high thermal conductivity. Even optical property, chemical stability, biocompatibility of this type of carbon nanomaterials is present. So, now different type of nanomaterials we have discussed. So, out of that today we will more details we will study the Fullerene. So, how the Fullerene particle carbon nanomaterials that is forms, and then proposed Fullerene mechanisms, how from one carbons to another carbons chain formations, and then a particular shape of spherical shape formations, sketch like structure formation is there, that we will discuss, and then reactivity of the fullerenes by different chemicals methods. So, different type of functional groups we can attach with that fullerene. So, for a specific applications we can discuss, or we will discuss that one. So, that fullerene materials that was discovered on the year 1985, and after that this materials is face centered cubic crystal structures, and it is cage like structures I said. So, there is carbon 60, 70, 78 number of carbons, that atoms that may be forms bonded with each others and form a cage like structures, and then this type of materials can be generated, or that materials would be forms. Okay. So, in this case, in these materials the diameters or dimensions that is very small, so less than 1 nanometer, 0.7 nanometer. So, therefore, these materials we can say it is a 0 dimensional materials also. So, and also the materials, the carbons bonded with each other, that is sp2 hybridized carbons, and these materials I said mostly when that fullerene is forms synthesized, then C60, that is number of carbons that fullerene is formed. So, that is mostly stable and perfectly spherical. So, this type of fullerenes. Apart from that, there are some other type of C70, C80, 78 type of fullerenes materials formations is there, or higher number of carbons may forms, but they are less spherical, not exactly spherical. So, some are distorted, but they are more still stable like C60. Okay. And applications, there are many applications I said, they can be imaging process, biosensing process, or targeted drug delivery. Many applications, energy storage also they can be used, electronics, semiconductors, or many applications are there. So, there it can be applied. These materials, one limitation is low solubility and hydrophobic natures, they are not easily soluble with the waters. So, therefore, they are hydrophobic in nature. Next is the how we can synthesize that fullerene materials from starting from a carbon material. So, it is plasma generations of carbons, that is by arc discharge methods or thermal plasma process. In this process we can generate, we can take a carbons materials, and then that would be converted into a plasma. Okay. So, then plasma would be deposited in a particular cold surface, and there that way we can generate that fullerenes. So, here various methods, arc discharge method, thermal plasma process method, that we discussed in our previous lectures also. So, here in these methods we can, I said, an electric arc will be developed, and that in that arc or discharge plasma of carbons, that formation should be there, and that would be deposited, and that would be separated by using a gas plasma jet, that fullerenes will be collected. Okay. And this thermal plasma process also similarly, here's thermal energy plasma that would be forms the carbon powder, that would be treated carbons powders, that would be forms a plasma. Okay. So, that would be continuous process. In this process where the carbon materials will forms, and continuously that would be coming out from that apparatus. So, here you can see it's electrodes 1, electrode 2, both will be taken in this particular plasma generations process. Here this plasma formations is there, and gas vacuum would be created and gas would be flow, and then that materials what would be formations over this particular place, that would be coming out from that device. Okay. So, by plasma generations process it can be means whether C60 or others allotropes would form. So, mass spectra we can use. So, using that, so different type of allotropes at what percentage or quantity that particular material is formations is there. So, that we can see. So, I said that materials having very small in size. So, diameter is very small, even that also may forms this type of crystals also. Okay. So, now one proposed model, so that how that fullerenes would forms from a carbons from the plasma, carbon plasma formations is there. When initially we have to take some carbons material, that is graphite, that would be heated up at high temperature, extremely high temperature, that would form a plasma, and then these carbons molecules or carbons atom formations is there, and after that it gradually formations this type of changed, and then formations of ring type of structure, that may be hexagonal or pentagonal arrangements. Here you can see these chain formations, ring formations, and at the same times they will be coupled with each others, and then this type of pentagon and hexagons type of structures will or ring that will be interconnected with each others. So, it may be too low temperatures or maybe too high temperatures. So, if it is too high temperature, 3-dimensional structure would forms, and if it is too low temperatures, then graphitic type of sheets formations is there, and in between temperatures this type of 60 or 670 type of materials will forms at in betweens, neither too high or too low temperature. So, this type of fullerenes type of materials will forms from that graphite, that was the started materials, that would be vaporizations at high temperature, and then by formations of chains and ring, and then cage like structures would forms or develop these fullerenes materials. Okay. So, yes, step by steps already have discussed. So, vaporizations of the graphites, and that would forms carbon atoms or small atomic carbons clusters, and then they would form say linear chains, and then large rings and polycyclic rings formations would be there, and then at the ends and fullerenes, that formations would be there. So, in the fullerenes you can see there are pentagons and hexagonal. So, both type of means structure is present, and therefore, they forms the cage like structures. So, here two hexagons rings that is present, they are also importance with the pentagons to form the cage like structures. So, now we will discuss once the fullerenes is formed. So, then that fullerenes can apply for many applications. So, in this I said that is not easily soluble in water. So, when it undergoes through nucleic additions by different carbons, nitrogen, sulfur, oxygens, that would be added, react with that fullerenes and form some functional groups, then they easily can be apply or used for any applications. Okay. So, then they can react with free radicals, or here you can see this is the fluorine structure. So, it can it is hexagonal structure, here hexagonal structures. So, in between two hexagons, so there is C66 carbon junctions is called. So, that junctions is very reactive. So, here any functional groups that can be attached, or that type of ester type of functional groups that was added with this particular sections or junctions. So, that apart from that, so there is Diels-Alder type of reactions is there. So, where this type of coupling means formations is there. So, here means fullerenes we can take, and then this type of compound is there, they will react with these fullerenes, and these 3 scandium atoms and 1 nitrogen atoms, they would be encapsulated inside of the C80 fullerenes cage. This is C80 fullerenes cage. So, when it would be react with this type of compounds, and then it would forms endohedral fullerenes by Diels-Alder type of reactions. So, this type of compounds we can form, and by using fullerenes as a starting materials with others substrates that we can attach react with that fullerenes. So, here's a different type of means the charged ion fullerenes that can be formed. So, here C60 plus, C62 plus, C3 plus, this type of different type of charged ion fullerenes that also is can be formed by using or when helium ions, excited helium, so or neons or inert gas or kryptons, that this type of atoms will be excited, and then they would be interact or react with the fullerenes. So, then this type of ionic compounds may form. So, C60 plus, so would forms. Okay. So, This is chemi-ionizations or pinning ionizations you can say, when this C60 that would interact with the excited inert gases. So, they thence that one electrons that would be lost by the C60 fluorines, and thence this type of ionic fluorines may forms positive C60 plus. Similarly, this H helium plus or neon argon plus, this type of ions. So, positively charged ions, when they will interact with these C60 fluorines, so then this type of C60 plus ion formations is there. Even so, when also two electrons also can be removed from the fluorines when this type of ions interact with the C60 fluorines. So, this type of C62 plus ion also forms along with C60 plus ones. Okay. Even if inert gas Ar2 plus, this type of double charged ions, they when interact with the C60 fluorines, so then this type of C63 plus ion, positively charged 3 plus ions, that also forms or possibility is there. Okay. So, here when this C60 plus ion fluorines is formed, so they can react with some others compounds. So, here iron pentacarbonyls compound is there. So, when C60 plus they will react, and then so this type of functional groups may form. So, this type of structures, it is speculative or hypothetical structure. So, this type of means structure formations is there, they later can be used for some other applications also, other purpose also. Means initially as fluorines that would be converted into C60 plus, and then iron pentacarbonyls can be react with this, and then this type of structure formations is there. Like that hydride, amines, any others functional groups or compounds also may react with this C60 ions, C60 plus ions. So, then this type of various structures may forms depending upon the materials with compounds with which there is C60 plus ions, that is fluorines, ionic fluorines, that is interacted. So, even C62 plus ions, that is also reacts with some this type of alcohols or nitrile groups, acetonitriles, like that type of compounds. So, or ketones, alcohols, aldehydes, esters also they may react with this C62 plus or C60 plus, and different type of compound formations or structure formations is there, where C60 fluorines is also building block, or that means structure is present in this compound. Okay. So, this type of derivatives we can say. So, similarly C63 plus, that is also may react with other different type of aldehydes, ketones, carbonyls compounds, they also reacts, and this type of different structures where C60 fluorines is present. So, our different derivatives we can means forms, or we can convert C60 into different type of structure. These are the structure are speculative or hypothetical structures. So, here this C63 plus ions, that is much more reactive than C62 plus, and C62 plus is much more reactive than C60 plus ones. So, thank you. So, these are the different fluorines materials or derivatives that we can prepare, and that can be used for various applications. So, thank you. So, today is up to this. Thank you.